Our clients and even some of our new developers are quite often surprised by the fact that we can get a release out in the first day or two of a project. And that's only really made possible because we're using the second wave of cloud technologies, or platform as a service, where instead of, say, Amazon providing the boxes and us providing all of the administrators to manage those boxes, what we have is that whole platform being managed by Google. And a class of engineer at Google that is fairly world famous in terms of their skills versus the best administrator that I can afford today if I'm managing an Amazon platform. And the way we present that back to our clients quite often is that, look, we've got this much money to spend on a project. What we want to be doing is delivering code to you for that money. We don't really, so if we've got a budget of $1 million or a budget of 100K, we want to spend all of that budget, 100% of that budget, on managing and delivering code for your solution to your users. And out of the 150 or so projects that we've run, we've had a number of those that we've run on Amazon infrastructure. And our metrics are generally around a third to a quarter of the budget being spent on the code in that case. Either through lower productivity because we don't have the same tools as developers to be able to do fast turnaround on laptops and local machines, or just from the fact that we have to have administrators, we have to pay people to architect, deploy, and manage the infrastructure, even if we're doing that on Amazon. And that's a cost element, but it's also a quality element to the infrastructure. So, on a Google, what I should walk you through in a moment is the fact that we can set that up in a few seconds. We sometimes lose sight of the fact that there's also a quality aspect of that. I'm a career project manager by trade, and I would say that the infrastructure that we have for free out of the box with Google that we can provision in a few seconds is far and above any infrastructure that I've spent maybe $1 or $2 million building over a 1 year period for a bank, for example. It's really quite amazing what you can get for free these days. And to pick that in a simple picture, any solution that we come up with these days on the internet or in a mobile platform has a bunch of infrastructure. I'll call those machines. But to get a solution out to market, you also have to assemble those machines together in a way that makes sense for that solution. So you have a bunch of administrators, system administrators, database administration, application, server administrators, network, and so on. And then, of course, you've got the developers who write the code. So in an Amazon world, in an infrastructure as a service world, we've moved forward in that we're no longer managing the machines. Amazon is managing those for us. But we still have to provide, as part of the project cost, the administrators and the system admins and so on, as well as providing the developers. Whereas when we're using platform as a service, like Google's cloud platform, Google also, as well as providing us the people to manage the machines and automate that process, they've also done away with the need to administer those machines. So we don't have people on our project that we have to pay for who are managing those machines. We just never touch them. So it's the difference between doing DevOps, if you're doing infrastructure as a service, in which case you need the DevOps people, versus not requiring DevOps at all, or let's call it no ops, because you simply don't have to do those tasks. So the way I'm going to demonstrate the difference really in tangible terms is I have an application that I've got on my local machine here. It's one that we prepared earlier for a client, which is just a little subject chooser for the enrollment process. We're going to create the infrastructure on which I'm going to deploy that. Okay, so the first step is we're going to create that infrastructure together. That'll take about 30 seconds. We're then going to quickly deploy the application that I have locally onto that infrastructure. And then what we'll do is load that up with 200,000 requests simulated from users. And I'll use that as a way to sort of demonstrate the sophistication of the application, the sophistication of the platform, and talk about some of the differences in quality between those two. And hopefully from that process you get a feel for the differences between managing infrastructure yourself and not managing infrastructure yourself. So let's get started. So this is the Google Cloud Console. Anyone with a Gmail account can create one of these things. To do what I'm doing today, you'd have to put your credit card down, but you wouldn't actually have to spend anything. So most of the stuff that I'm doing here, I could do 5 times a day, and I won't actually be charged for any of the things that we're talking about here. So creating infrastructure in the Google world is as simple as literally clicking at this thing, saying create project, and giving it a unique identifier that no one else in the world has used. So I'm going to use 3 weeks dash, let's do subject planner. Okay, it's telling me down here that that's free and no one else is using that particular name for infrastructure across the world. You can see up here in the right hand corner it's gone away to have a bit of a think through that. This process used to take between 5 and 7 seconds. In the sophistication it seems to be taking longer and longer. But either way, you're not spending $250,000 and wasting 3 to 6 months of your project architecting something that someone else could architect for you, and deploying those machines and assembling them together into a structure that makes sense for your application. And if you think about it, it's a bit dumb that we're doing that still these days, because every internet application or every mobile backend looks the same. There's nothing different about these things anymore. So that's us done. We've now completed that task. That infrastructure has been created, and I can actually go and visit that at subject-planner.appspot.com. This is just a holding area that you can access your application directly. And as you'd expect, there's nothing there. We've just created that infrastructure. So what we need to do now is we need to actually take an application and deploy it up there. So excuse the slightly technical nature of this step. We've just created a thing called Subject Planner. So what I'm going to do here is just tell this thing where I'm going to deploy to. So we've used the same name that we've created the infrastructure for. And I'll get it to update. Let's try the right command, shall we? And what it's doing now is basically packaging up my application that's here locally on my laptop, and shortly after doing some tests and making sure that's all hanging together, it'll load that up onto our new piece of infrastructure on Google Cloud. So the whole process that we've just gone through there has taken somewhere in the region of 2 minutes. To set up infrastructure, which is production grade infrastructure, and deploy our existing application up onto that infrastructure. This is exactly the same process that we've used to run 140-ish projects, 135 projects, for companies like the Good Friday Appeal, for example, who take $16, $17 million in a day through that platform. And let's have a look at what that looks like at the back end. Okay, so we've got a prod infrastructure here that's just been deployed. And at the moment, what we can see here is that we don't have any instances that are managed by Google for us, because actually Google has the sense to say that if no one connects to this, we shouldn't run it up by default. That comes in really, really handy when you've got an application that's used maybe between 8 o'clock in the morning and 6 at night, because for most of those projects we pay in the region of $1 a month. Because Google will very kindly shut that down when it's not in use. And the first person that hits it in the morning warms it up. It takes about 10 to 15 seconds. And from that point forward, it's serving up live traffic. Saves a huge amount of money because Google's actually only charging you for 1 minute at a time for the number of instances that you're using. So let's go to our app now. Took a little bit less than 10 seconds, so that's about 5 seconds. And now our application is live. And if we sort back to the console, the Google Cloud console, we can see here, if we refresh that we've now got one instance running in the cloud. So it gives you a feeling for the difference between that and setting up infrastructure. One of the challenges that we have in discussions when people are arguing the relative benefits of platform versus infrastructure is we give them an application, or we suggest to them that they have a pre-baked application of their own, and we say, okay, great, let's have a race to create some infrastructure and load our app up, and then load it up with a couple of 100,000 requests. Normally in an Amazon world, that's going to take hours or days. In our world, that takes a few seconds. And what we'll do now is we'll load that up with a simulated load of 200,000 requests, and we'll use that to sort of get a feel for how the back end responds. So this is our app, still serving. And in the meantime, on the back end, the clever people at Google have figured out that this thing's being hammered and have speculatively started up 4 separate instances. And you can see here the number of requests that are being hit on the server is incrementing quite significantly. And you can see the one at the bottom is taking very few requests. What will happen after some time here is it'll actually try and figure out whether it really needs to be scaling up in advance, and it might stabilize and it'll probably drop one of these machines off eventually. But what you've got there is a simulated load of 200,000 connections that's being quite easily managed by 4 machines. Depending on the application, it may or may not cope that well. But at the end of the day, you're not touching the infrastructure. It's just scaling automatically for you. And the final thing I'll demonstrate here is just redeploying the application. If I make a change to my application, some minor change to maybe the title of the page, doesn't really matter what change I'm making here, and I'm going to do another update here. In fact, what I might do is update to another slot just to demonstrate to you the difference between those two things. So at the moment I've deployed to prod, and what I might want to do here is actually temporarily deploy, leave all the prod people by themselves, and actually deploy this new version to a new slot. So I'm going to do that. Same process as before. It'll probably take a couple of minutes or a minute. While it's doing that, I might sort of demonstrate one of the key features of this platform. So as well as having a massive big data platform that's created for you for free, as well as automatically provisioning things like machine learning engines on this application, some of the sophistication can be seen in things like logging. So, I've got 4 machines running at the moment, and these machines may disappear tomorrow. But in the meantime, I can access the logs across all 4 of those machines, and in fact, for the next year, I'll be able to access these logs. So all the requests that are coming in at the moment are coming in from my machine, as you can see here, the curl command that I issued in the browser. And I can see every single request here going back to the first request. I can search through them, I can export them, and that's extremely powerful when you're trying to detect an error that happened 4 weeks ago. You want to be able to do that. You can even load this into the big data platform. So that's an example of some of the sophistication this platform has, and that's just one thing. Distributed caches, queues, automatic deployment of queues, back-end services, schedulers. These are all the things that you get for free out the box. The developer can just hook those in through configuration, and every environment that the application goes through gets to benefit from that. Will automatically provision those services that are required. So let's have a look at our versions. It's going a little bit slowly at the moment because I'm loading up from my machine here, so I'm actually constraining my own internet bandwidth rather than slowing down the server. So still waiting for that to load up. Success. Great. So here you can see we've deployed 2 versions. At the moment, all of the traffic is still going to the prod, but you'll notice that nothing changed in the process of me deploying that. So we're still serving up requests, it's still taking tens of thousands of requests, and in the meantime I've deployed a new to the Smoke environment. And what I'm going to do now is I'm actually going to have a quick look at that to see if it's different from the original. So I'm going to go smoke.subjectplanner.blogspot.com, and that's me directly mandating that I want to connect to that new server instance, whereas all of the normal traffic is still hitting the default instance. So you can see here that I've changed the title here as I did back in my developer tool. So let's say I have a play with that and I realize that, okay, it looks good, we've smoke tested that. That's the current prod version, that's the one in smoke, and we decide that we're all good, let's go for it. All I have to do here is tell it that I want to go to smoke and migrate the traffic, and we're done. And you can see here that it's migrating the traffic across. Won't take it long to do that. And eventually 100% of the traffic will be migrated across the smoke, and you're done. At that point you can actually decommission the old one. In fact, what we should see here is that some of the instances are serving one and some are serving the other. So this is prod. So you can see that the requests are just starting to die down off this. And if I look at smoke, it's also serving a whole bunch of different machines here on smoke. So hopefully that's a visual way for you to try and understand the difference between managing your own infrastructure on Amazon versus inheriting a sophisticated and highly automated and well-engineered platform from another provider, such as Google. There are some competing services on Amazon that are beginning to mature, whereas I would say that Amazon stole the lead on the market for managing machines. I would say that Google has well and truly stolen the market for managing the whole platform for you. I think eventually there'll be two players in that race, but for the moment, if we want to spend the bulk of our budget on writing code and deploying a solution for a customer, this is how we do it.